All right, so we've got a couple really exciting days filled with the quadratic formula. And today we're going to start with just factoring quadratic expressions. Some of you may or may not have seen the box method for multiplying binomials. This is a binomial, and it's written in a 2x2 box like that. Last year, a lot of students had seen it, but I remember the one year that I taught math to, I don't believe that I ever taught the box method. So if you didn't learn this method, don't worry about it. It's just another method or option available to you that some students like. Last year, my students seemed to really like the box method. It's not something that I personally prefer, but it's whatever makes sense the most to you. So there is an example if you need a refresher on the box method or if you're trying to learn the box method. It's how to multiply those binomials. So we're going to take this binomial here. We're going to have this x plus 5 we'll write on the top, x plus 4 we'll write on the bottom. X times x equals x squared, x times 5 is 5x, 4 times x is 4x, 4 times 5 is 20. So then you can write it, your answer, like this, okay? So we have that x squared plus 4x plus 5x plus 20, and then they combine the like terms to get that 9x. Okay, so we're going to use the box method to factor x squared plus 10x plus 21x. So we're kind of going backwards from what we just did. They have already filled out the box for us, so that's not something that we need to concern ourselves with filling in the box. We just need to work backwards. So for this one, what times what is x squared? Well, it's an x and an x. For this box, what times what is 3x? Well, I already have an x over here, so x times what? X times 3. Down here, pretty similar. We have an x. X times what is 7x? 7. And then we have filled in already 7 times 3 is 21. And if that didn't work out, if those two numbers that you were left with, if they didn't work out, then you have some problem that you need to fix before moving on. And then from here, our answer, we're not totally done, is going to be x plus 7, which is this from right here, and x, or times x plus 3. Like that. That would be our answer. So we just factored this. Okay. Let's move on, and I'll show you another method coming up. But for number 2, for each row in the table, find a pair of numbers with the given product and sum. So we're trying to find a pair of numbers where the product, so two numbers multiplied, is going to give me 30, and the sum is 11. So two numbers added will give me 11. So multiply to 30 and add to 11. So for this, it might be helpful if you write down, okay, what times what is 30? Well, 30 times 1, and also 5 times 6. Oh, I skipped one. 2 times 15, 3 times 10, and 5 times 6. Okay. And then which one of those 4 is going to add up to 11? Well, it's this 5 and 6. I already kind of gave you that. So 5 and 6. And you could do the same thing for the rest of them. So now we also need a product of 30 still. Okay, product of 30, except this time they're going to add to negative 11. So out of these 4 combinations, which one will add to negative 11? Well, if I made my 5 and my 6 both negative, negative 5 plus negative 6 will give me negative 11. So negative 5, negative 6. And we can do the same thing for the rest of them. Product is 44, adds to negative 15. So we have 44 times 1, 2 times 22, 4 times 11, 5, 6, 7, 8, 9. I think that's it. Okay, so what will add up to negative 15? Well, I can make one of these negative 44 plus 1. That's definitely not even close. Negative 22 plus 11, again, not even close. 4 plus 11 gives me a positive 15. If I want negative 15, I can always make both of them negative. So my answer is negative 4 and negative 11. Okay, so I think you can see the pattern kind of going on here. Go ahead and fill in those last 3. You can pause the video. I'll write the answers in so you can check and you don't have to go to the answer key. So pause the video here and do those last 3. Okay, so your answers I wrote down for you. Okay, so for number 3, we're going to use the pattern x squared plus the sum of the numbers x plus the product of numbers will equal x plus a number times x plus a number. To factor each of these expressions, and then we'll use FOIL at the end to check our results. So I'll explain that to you when we're done with the first one, how to check our results. Okay, so this needs to be the sum of numbers. This needs to be the product of numbers, just like we did up here. Okay, so it needs to multiply to 12, but add to 7. And then there's a couple of rules in regards to my signs. So when both signs are, when this sign is positive, it's going to be the same sign. Okay, same sign. What is the same sign going to be? It's going to be the same as this first sign. So they're both going to be positive numbers. Okay, so it'll look like this. Something plus, so it'll look like this. X plus something times x plus something. Okay, so they need to multiply to 12. So let's write down all the factors that go into 12. So 12 times 1, 2 times 6, 3 times 4. Which one of those is going to add to 7 if they're both going to be positive? Well, 3 and 4. So 3 times 4 is 12. 4 plus 3 is 7. And FOIL just stands for first, outside, inside, last. So first, outside, inside, last. So we're going to take the firsts, that's the first, x squared, plus the outsides, and change colors here, outsides, insides, and the lasts, plus 12. And then we can combine like terms, x squared plus 7x plus 12. And that is my original quadratic expression there. And then moving on to B, we have x squared minus 12x plus 20. So again, it's going to be the same sign because this is positive. So same sign. What are the signs both going to be? They're both going to be negative. Okay, so it'll look like this. X minus something times x minus something. So it'll look like that. We just need to figure out what these two numbers are. So I'm going to, what times what is 20? So I'll list all of those. 20 times 1, 2 times 10, 4 times 5. Which one of those is going to equal negative 12? Both of them are going to be negative, okay? So make both of those negatives, and our answer will be x minus 10 times x minus 2. Hopefully this is like kind of ringing some bells and you're remembering how to do this a little bit better. Okay, next one. These ones are a little bit harder because now my second sign is negative. So that means it's going to be different signs. Okay, how are they going to be different? Well, one's going to be positive, one's going to be negative. How do you know which one is going to be which? Well, this first sign is positive, so the bigger number is going to be positive. And then we'll take what times what is 8. So we'll write all of those. 8 times 1 and 4. 8 times 1 and 2 times 4. Okay? The bigger number is going to be positive. So 8 is positive, 1 is negative. 2 is negative, 4 is positive. Which one of those is going to add to 2? It'll be x minus 2, x plus 4. And then this last one, same thing. Second sign is negative, so there'll be different signs. How are they going to be different? Well, the first sign is negative, so the bigger number is going to be negative. And then we'll list out everything that goes into 35, 35 times 1, and 5 times 7. So the bigger number is negative. So 35 will be negative, and 7 will be negative. Which one of those two will add to be negative 2? It'll be x minus 7, x plus 5. All right. And then moving right along, some more reading for you if you're still getting a little bit confused. Some answers. They're going over the guess and check method on this one. Always a fantastic option. Okay. Again, pay attention to signs to help you factor a little bit quicker. All right. Number 4, if you don't know how to solve these, I do recommend going back through and reading some of these examples. Okay, so factor each quadratic expression. So both signs are going to be the same, and they're both going to be positive. So I'll set that up. Okay. Now this time I have a number in front of the x squared. I have a 4. So that means my options are going to be a 4 times 1 and a 2 times 2. And then over here it's 1. So the only option I have is 1 times 1. So I can fill those in right here. I only have one option. Nothing's going to change there. Now, first, outside, inside, last, gotta be 5x, okay, when I distribute. So if you want to do the guess and check method, totally fine. We'll just plug in numbers, see which ones work. So let's just try 2 times 2. Okay, so if I did that, well, that'll give me a 4x squared. Perfect. On the right track. Now if I do the outsides plus the insides, so it's really hard to show you on here. The outsides, 2x, plus the insides, different color, this guy and this guy, plus 2x. Well, that'll only give me a 4x when I add those together. So that's not going to work out for me. All right, back to the drawing board. I need to replace those. 2 times 2 is not going to work, so let's try 4 times 1. Okay, so still same thing. 4x times 1x equals x squared. Good. Okay, now the outsides, so plus 4x, plus the insides. Okay, plus 1x. 4x plus 1x is a 5x. And then the lasts, this is last, plus 1. So yes, 4x squared plus 5x plus 1 will give me that answer. Okay, so my answer really is this guy right here. So we'll highlight that. I got messy pretty quickly. Okay, we'll shrink this down and move on to the next one. Okay. B, it'll be pretty similar, except this time our second sign is negative, meaning that the signs will be opposite. So we'll have x plus and x minus. Oops. Okay. My first number is 2. So my only possibility is a 2 times 1. 2 times 1. My second number is 6. So I can have a 6 times 1 or a 2 times 3. All right. And then my end goal is to get my middle term to be plus x. So 1x. So I think probably the easiest way, unless your teacher taught you a really great method last year or in Math 2, my preferred method to always fall back on is guess and check. I could never remember all of the little rules. So guess and check is totally fine for me, even if it takes a couple extra minutes. Okay, 6 times 1, just instinctually, I don't think 6 times 1 is going to get me anywhere near a 1x. So I think I'm going to skip that one for now, and I'm going to go to the 2 times 3. So I'm going to plug the 3 in here and the 2 in here. And you're like, well, why did you pick that? Well, 2x times negative 2 is going to be negative 4. Negative 4x. And then this and this will give me a plus 3x. So I kind of was like instinctually, I know I'm doing the outsides, and I know I'm multiplying the outsides plus the insides. So I'm on a pretty good track. It equals negative 1x. Okay, that's kind of close, just my signs did backwards. So let's see, what if I switched my signs around? Okay, so I'm going to make, oops. So let's see, I'll make this negative and I'll make this positive. Then let's see, okay, so outsides will give me a positive 4x, and then insides minus 3x. And that gives me a plus x. Perfect. Okay, let's FOIL and see if it works out all together in the end, if I had any like big mistakes that I didn't notice. Okay, so firsts are these ones, so 2x squared. Outsides, so plus 4x. Insides, negative 3x. And then lasts, these guys, minus 6. And when I combine my like terms, 2x squared plus x minus 6 is exactly what I had before. So perfect. And then from here, guess and check approach can be fast with some quadratic expressions and slow with others. So just keep that in mind. You can absolutely always use the box method if you so choose. Box method is, again, something that I never really learned how to do in high school, so it's not my preferred method. I find it to be longer and more tedious just because I'm not as confident in that method as I am in guess and check. But if you want to use the box method, and that's totally fine, just draw a box, solve by the box method. Here's a little bit reading for you if you're like, wow, I really hate guess and check, I'm never going to figure it out. Here's some reading on the box method. I'm actually going to skip the box method just because it's not my favorite. And yeah, so we're going to skip those. If you want to work on them, go for it. We're just going to start with number 7. So factor the expression completely. That is, factor out a GCF if one exists, and then factor the remaining quadratic expression using any method from this section. So if we notice 5x squared minus 10x minus 40, those are all pretty large numbers. Your first step should always be, can I factor out a GCF? Can I make these numbers just a little bit smaller and a little bit more manageable? Because if you tried to solve this just like it is, 40 would be 40 times 1, 2 times 20, 4 times 10, so on and so forth. Like, there's a lot of different combinations. You have a negative here, so that means that there's a lot of different possibilities of what could go where. A lot of room for mistakes and errors if you're using guess and check. So 5, 10, 40, I can definitely factor out a 5 in order to make my factoring just a little bit easier. So we'll factor out the GCF of 5. I'm left with x squared minus 2x minus 8. Okay. Now I can kind of ignore that 5 in the front. We'll bring it back in the end. But right now I'm just looking at this right here as I'm factoring. So we have x minus x plus. My signs are different, and the bigger number is going to be negative. Those look like equal signs now. Okay. Different signs, bigger number is going to be negative. So for 8, we have 8 times 1 and 2 times 4. So what's going to get me to negative 2? That's going to be this one. Bigger number is negative. Negative 4 plus 2. Then I'm also going to bring down this 5 in the front. If you're not too confident with your math and your factoring, you can use the FOIL method to double check. Remember, firsts, x squared, outsides, plus 2x, insides, minus 4x, and lasts, minus 8. Combine your like terms, and then that was exactly what was inside of my parentheses up here. Just don't forget this 5. It has to be added back in at the end. And then this right here is your final answer. And then the last one we'll go over is number 8. Nothing different. We're still going to factor, except this time we're going to solve for x. There is an example that you can look through up here. Obviously, I'm not going to read it to you because I never do. So first step is going to be to factor. Okay, this sign, oops, I thought that was the highlighter. This sign is positive, so meaning that we're going to have the same sign. They're both going to be positive. So x plus something, x plus something. And then we just have to figure out what that something is. So it's going to multiply to 35 and add to 12. So 35 times 1, 2, 3, 4, 5 times 7. I think 3 might work. 3 times... No, I don't think 3 works. No. Okay, I think that's it. What adds to 12? Well, 5 plus 7 equals 12. Okay, now we're not done. We only factored. We need to solve for x. So what I'm going to do is I'm going to take each of these parenthesis sets and set them equal to 0. X plus 5 equals 0. X plus 7 equals 0. X would equal negative 5. X would equal negative 7. Why is that? Why did we set them equal to 0? Well, this, I guess I forgot to write that in. That equals 0. Now, this is some number times some number, right? Yes, good answer. Something times 0 is always going to equal 0. So we either need to make this equal to 0 or this equal to 0. Because then in the end, the whole thing will just equal 0. It'll all cancel each other out. So we can plug in negative 5. Negative 5 plus 5 equals 0. Or we could plug in negative 7. Negative 7 plus 7 equals 0. Hopefully that made sense. It's quite hard to try to explain this when we're remote and I can't actually like point things out. So if you have any questions, make sure you email me and let me know.